let's go ahead and get started with Unit 7.2, Modeling Tax Schedules. Our objectives for today: construct income tax graphs using compound equations. We do have a few vocabulary words here. Hopefully you've reviewed those in your textbook. If you need to go back and refer to those, please do so with the textbook. So for our first example, it asks us to model the tax equation shown in the in tax schedule notation, interval notation, and compound inequality notation. So for purposes of not having enough room on this page, I've gone ahead and I have actually created all three of those here on the next page. What I'd like for you to do is go ahead and press pause at this time, and you're going to go ahead and copy this whole chart here. So you're going to be copying everything from all three columns all the way down to the bottom. Once you're done, go ahead and press play, and we'll talk a little bit about it. Now, I did notice real quick that not all of my numbers actually copied over, so let me go ahead and get those in real quick before you press pause. And then as soon as I get these written, go ahead and press pause and write all of these values in. Sorry, this last one is 357700. So please press pause, go ahead and fill this in, and when you're ready, come back. All right, so looking at tax schedule notation, it's basically making the statement that it is over 0, but not over 16,050. In an interval notation, that means that x here in the center is greater than 0, but less than or equal to $16,050. And then a compound inequality notation is making two statements, which makes it a compound statement. First, x is greater than 0, and x is also less than or equal to 16,050, so it offers the range. And it does so for each individual range all the way up to 357,700 and over. So for the check your understanding, it says write the tax schedule notation, interval notation, and compound inequality notation that would apply to an income of $172,876.99. What I'd like for you to do is go ahead and press pause for a moment. Rather than rewriting the whole thing, I will tell you that it is one of the lines that you just wrote. So I want you to just draw an arrow to the one that you believe fits this particular situation. When you're ready, press start and we'll go on. All right, for $172,876, if I look at all of my intervals here, that one is going to fall right into here because it falls between $131,000 and $200,000. So this particular line, all three of these, is what it is asking you to write. Moving on to example number 2. Here we've got our tax equations, and here we've got our tax table that we looked at yesterday. And the question is, how does the piecewise function relate to the tax computation worksheet? So we're going to go ahead and take this first example right here, where it states at least 100,000, but not over 131,450. And let's see if we take the equation, how they arrived at the $7,312.50. So first off, if I go back and I look at the equation, the actual equation is right here at my 8986. So we're looking at these equations. I apologize, right here. So let's go ahead and look at y equals 8986.50 plus 0.25 of x, the quantity, x minus 65,100. So when we look at this, right now, column D seems to have no real meaning. We don't understand how they got these erroneous information. But there actually is mathematical significance to it, and I'm going to find that beginning by using my distributive property. So I've got y equals 89, 86, 50 plus 0.25x minus 16,275, which is what I get when I multiply 0.25 and 61,000. Next, I go ahead and I'm going to combine my like terms, and guess what? I end up with y equals 0.25x minus 73, 12, 50. So it's simply taking that equation, doing our distributive property, and then getting the actual equation into my slope interval form, or y equals mx plus b. So the tax equation for incomes of 131,450, but not over 200,300 is as follows. Simplify the equation and explain the numerical significance of the slope and the y-intercept. Go ahead and press pause. Solve this. When you're ready, go ahead and come back. All right, so let's go ahead and break it down. Again, I have y equals 25,550 plus 0.28 of x minus 131,450. When I go ahead and I distribute these, I end up with y equals 25,550 plus 0.28x minus $36,806. Finally, I get y equals 0.28x minus 11,256. So the significance, it looks like at this point my slope is going to change, and the previous was 25%, and how do I know that? It had a slope of 0.25 at this point, because we're looking at our slope. So what it's saying is at this point the slope actually changed. So the line is not a linear equation from that point, it's actually moved to a 0.28 for our slope. Now, as far as the y-intercept, that tells us the location that the slope actually changed. All right, example 3 asks you to express the equations in the married taxpayers filing jointly schedule in y equals mx plus b form. So we're basically going to take this and we're going to get them all into slope-intercept form. And I've gone ahead and I've done that right here. So go ahead and press pause. Please again copy these down, all of them here in this chart. And when you're ready, go ahead and come back. All right, so here you see the actual tax equation itself, which we saw in the previous chart. And now I've done the distributing and I've combined like terms to actually get my slope-intercept form. So now let's do something with that. It says use the appropriate equation from example 3 to determine the tax for an income that's $46,000. So we're looking at an income of $46,000. And so let's see where that's going to actually fit. And it looks like it's going to fit right in here. And how did I get that? Well, let's go back and look at the chart. So we have to go way back here. And if we look at our chart here, we can see that our income for $16,050 to $65,000 is this equation. Once we multiplied that equation through on the chart that we just did, we ended up with this chart. Here's the equation that we ended up with. So we're going to actually plug that in. So we get y equals 0.15 times 46,000 minus 802.50. Oops, decimal in the wrong place. Give me just a second to fix that. So once I do my multiplying through, I end up with y equals $6,097.50. All right, looking at example 4, it says examine the piecewise function compressed from the 3 equations in example 3. So the 3 equations that we're talking about in example 3, we're going to look at these top 3 equations. We're looking at number 1, number 2, and number 3. And we're actually going to graph those in our graphing calculator. So you're going to go ahead and go into your graphing calculator. On the top left-hand side, you are going to see a y equals button. And you're going to go ahead and click on that, and you're going to put in the following equations. Give me a second. So we've got our 3 equations here. The first one being, let me go back and we'll write them down so you know what you're plugging in, and then we'll come back to the actual graph. So the first one where it says y1, y1 simply equals 0.10x. y2 equals 0.15x minus 802.50. And that goes in the x2 spot. Sorry, the y2 spot. The y3 spot will be 0.25x minus 7312.50. So we've got exactly as the equations are here. We're going to go ahead and write those into the equation. And then you're going to go ahead and you are going to create your minimum and maximum. And you're going to do that by clicking on the window right next to the y equals button. I want you to go ahead for an x min, put in 0. For an x max, put in 250,000. For a y minimum, you're going to put in 0. And for a y maximum, you're going to put in 25,000. Now, you're going to see also a button that says X SCL. And that's right below where it says X max. I'd like you to put in 15,000 for that, please. And then for the Y SCL or Y scale, I would like for you to put in 2,500. Once you are done, on the far right side, I want you to hit the graph button. And you should be looking at 3 lines on a graph that look exactly as you see here on the screen. And that does it for 7.2. Good job, everyone.